We have, these massive server farms running supercomputers that can pass the bar exam in seconds. So, okay, let's unpack this. Why can't any of them fold a basket of toddler socks?
It really is wild when you think about it.
Right, welcome to the deep dive. Today, we are pulling from a new interview with AI pioneer Fei Lai to explore the next frontier of artificial intelligence, which is spatial intelligence.
Yeah, it really highlights a fascinating blind spot in how we've been building AI up to this point. I mean, we have essentially built brilliant disembodied brains.
Right, and as anyone listening already knows, current large models are heavily constrained by the reliance on text. But the source points out just how lossy that language-based training is when you try to apply it to actual physical action.
Exactly. You simply cannot mathematically encode the physical friction of a basketball slipping from your fingers or, the subtle weight shift of driving a car purely through text tokens.
It's not enough data.
Right. The physical world does not translate perfectly into words.
It's like trying to learn how to ride a bike by reading a dictionary. I mean, you can parse the word balance a million times, but that semantic understanding won't keep you from scraping your knee on the pavement. The physical nuance is totally lost.
That is a great analogy. And this disparity makes complete sense when you look at the evolutionary timeline. If we connect this to the bigger picture, we tend to think of language and logic as the absolute peak of intelligence because, well, they evolved most recently in humans.
Right, because language feels so advanced to us.
Exactly. But spatial intelligence, things like perceiving depth, mapping an environment, reacting to gravity, that took biology over 500 million years to optimize in animals and humans.
Wow. So we've managed to crack this relatively thin, newer layer of cognitive intelligence with LLMs. But that ancient, half-a-billion-year-old physical intuition is much deeper and infinitely harder to reverse engineer.
It really is. And since we can't afford to wait another 500 million years for a computer to naturally evolve physical intuition, researchers are artificially engineering it by breaking spatial intelligence down into smaller, solvable algorithms.
Right, the four pillars.
Yes, the source breaks this down into four interacting pillars: understanding, reasoning, generation, and interaction.
Okay, let's look at how those actually execute together in a real-world scenario. Say, we want a robot to simply hang a shirt in a closet.
Perfect example. First, the robot's vision system has to actually recognize the 3D geometry of the closet and the hanger. That is understanding.
Got it.
Then it needs to map a safe trajectory for its arm to move without smashing into the door frame, which is reasoning.
Right, and then it has to physically manipulate the fabric onto the hander, the interaction piece.
Map.
But wait, so AI can already generate 2D images easily, but is true 3D generation the real bottleneck holding back robotics? Where does generation fit into hanging a shirt?
That is the exact bottleneck holding back the entire robotics field right now. A 2D generated image is just a flat array of pixels.
It has no actual depth.
Right. It doesn't contain any underlying physical truth. To successfully interact with that shirt, the AI has to generate a real-time 3D simulation in its mind's eye of how that specific fabric will drape, fold, and react to gravity before it ever makes a move.
Ah, because predicting physical states in 3 dimensions requires calculating mass and physics, not just, guessing the color of the next pixel.
Precisely. 2D generation is mature, but dynamic 3D generation is a completely different computational beast. And that missing 3D spatial generation layer is why a company called World Labs is currently focusing on this exact problem.
Oh, they're building the foundational models for this.
Yes, they are focusing specifically on building these foundational 3D models. If you can solve that predictive 3D generation, you unlock the missing link for autonomous robotic interaction, plus entirely new paradigms in game development and architecture.
So for you listening, this means AI is actively preparing to step out of the data center and into our physical environment. We aren't just talking about text boxes on a screen anymore.
Which brings up a really compelling implication to think about. If AI finally masters this spatial intelligence and takes over deeply tactile chores like folding laundry or cooking, how will that change our own physical connection and agency in the real world?
Oh wow, that is a wild paradigm shift.
Yeah, if computing can seamlessly map and merge with the physical environments we walk through every day, the concept of sitting at a desk to interact with a machine might become entirely obsolete.
It really turns out teaching a machine to fold laundry might just completely redefine how we experience the physical world.